Hello and welcome to another math video. We're talking about the surface area of prisms today. We're going to dive right in and start talking about a rectangular prism. This is what a rectangular prism looks like. It's basically a box. Hopefully you'll notice that the sides of the boxes, some of the sides are very similar. We've got a side over here. I'm going to label it 1 and 1. So the right side over here and the left side. In blue, we're going to do the front and back. They're very similar as well. And then in green, we're going to say, okay, the top and the bottom as well. So hopefully, I don't know if I confuse you more, but hopefully you can kind of see that this box is made up of 6 rectangles, but the 2 of the rectangles are the same on the sides, 2 of the rectangles are the same front and back, and 2 of the rectangles are the same on the top and bottom. Now your formula sheet has a formula for the surface area of this object. It says something along the lines of the surface area of this object is 2 length times width plus 2 length times height plus 2 width times height or something like that. That's great. That's perfect. No problem. You can use that if you want, but it's much better to understand the idea of surface area by taking a look at the sides, by summing up or adding up all of the surfaces of this object. That's the best way to go about doing a surface area problem. So what we're going to do is we're going to say the surface area of this object is going to be equal to twice area 1 in red. Okay, so the sides, the 2 sides, and then we're going to add twice area 2, so the front and the back, and then we're going to add twice area 3, so that's top and bottom. And since they're all rectangles, it's just whatever the dimension times whatever the other dimension is. So let's try this out. The surface area of this object is 2 area 1. What is area 1? Well, we know area 1 is 3 inches tall, but it's also 9 inches deep. So 9 inches this way as well. So that's, okay, there's 2 of them, and its dimensions are 9 inches times 3 inches. And actually, I'm not going to include the inches because that is going to get very messy. So it's 9 inches times 3 inches. Perfect. Now there are 2 front and back. What are the dimensions of the front and back? Well, it's 3 inches tall by 12 inches wide. So 2 of them, and they're both 3 by 12. And then there's 2, the top and bottom. What are the dimension of those? Well, it's 12 inches long and 9 inches in depth. So there's 2 of them, and they're 12 by 9. So if we wanted to calculate the surface area of this object, we'd have to just multiply all of these numbers and then start summing them up. You can do this all in one calculation if you want to. So in your calculator, you can just go 2 times 9 times 3 plus 2 times 3 times 12 plus 2 times 12 times 9, or you can do this separately and then add it up together. It doesn't really matter to me. We're going to do it separately. So 9 times 3 is 27. 27 times 2 is 54. And then we're going to add 3 times 12 is 36. 36 times 2 is 72. And then we'll add 12 times 9. 12 times 9 is 108. 108 times 2 is 216. And when I add all of these values up, the surface area of this object is going to be 54 square inches. So inches squared, inches squared, inches squared. So 54 plus 72 plus 216 is 342 square inches. Perfect. Now I know that the units are square inches because area is always in square whatever units we're using. Volume will be in cubic whatever units we're using. Now we're going to move on to triangular prisms. Triangular prisms are without a doubt harder than rectangular prisms. The only side that is repeated is the triangular side. So if you see kind of we have this front triangular piece here, and then in the back we also have another back triangular piece there. And so there's a triangle at the front and a triangle at the back. What this is going to be, the area, the surface area of this object is going to be 2 base times height divided by 2, because it's 2 triangles, and then, and then it'll be our area 1, area 2, and area 3, where we've got area 1 is right here, area 2 is on the bottom, and then area 3 is over on this side. So hopefully that makes sense. Let's try this out. The surface area of this object is going to be 2, and then what's the base of this triangle? Well, it looks like it's 5.2 feet. Okay, no problem, 5.2 feet. What's the height of this triangle? The height is 3.9 here. It's the same as this line and this line are the same. So 3.9 feet divided by 2. That's convenient. And then we're just going to add up our areas. Area 1 is this rectangle that's 2.4 by 3.9. So 2.4 by 3.9 plus area 2 is on the bottom. It's got dimensions of 5.2 feet by this line here, and this line is the same as 2.4, so it's 5.2 by 2.4. 5.2 by 2.4. And then, plus I'm just going to add it on at the bottom. We've got this rectangle in the back here, and it is 6.5 by 2.4. 6.5 by 2.4. So if we look at this, the 2 and the 2 cancel out. So I am going to get 5.2 times 3.9. 5.2 times 3.9 is 20.28 square inches. 2.4 times 3.9 is 9.36. 5.2 times 2.4 is 12.48. 6.5 times 2.4 is 15.6 square inches. So when we add this all up, the surface area is going to be 57.72 square feet. Okay, we're going to look at the surface area of a cylinder now, and let's just start off by drawing a cylinder. So here's a cylinder. Hopefully that kind of makes sense. What are the parts to a cylinder? We've got a top. That's a circle. We've got a bottom. That's also a circle, so that's represented by this here and that here. What are the areas of a circle? Well, that's pi r squared, and that's pi r squared as well. But if we were to take this lateral side, the part that wraps around it, if we were to cut it down the middle and unwrap it and kind of like open it up and stretch it out, it would end up making a rectangle is what we would make. So let's try and figure out what are the dimensions of this rectangle going to be. Well, The part that stretches from the circle to the circle, this here, all the way up from the top to the bottom, that's the height of the cylinder. And this part that stretches from one side to the other, that's the part that used to stretch all the way around. And what do we call that? Well, we call that the circumference of a circle. What's the circumference of a circle? That's 2 times pi r. So this is 2 pi r. So if we were to take those two pieces of information, that the rectangle is height across and 2 pi r up, well then the area of that rectangle is going to be 2 pi r h. That's the area of this rectangle. If we add it all up, we take two circles, so 2 pi r squared, and we add it to this rectangle, which is 2 pi r h. That's the formula for the surface area of a cylinder. You don't necessarily need to know that, but it's good to understand where that information comes from. So we'll try out an example. We want to do the surface area of this cylinder. And so, okay, the surface area of a cylinder is 2 pi r squared plus 2 pi r h. No problem. 2 pi, what is the radius? The radius looks like it's 5 feet. So 5 squared plus 2 pi, again the radius, times the height. Well, this cylinder is 12 feet tall. 12. Perfect. And because pi is an irrational number, we're going to get a really long decimal number here. So we'll just do this calculation all at once. And if I punch that into my calculator, I get 2 pi times 25 plus 2 pi times 60. So I'm going to get 534. We want to measure to the, or round to the nearest tenth. 534.1 square feet. Perfect.